This is a demo for game 575 PA5, the animation system. So let's first talk about the converter here, the import scene. In order to get all this data, I created custom headers, package header and chunk header. We used it before. I have the hierarchy data, animation data, and bone data, which is going to store the data. And the quad function here, a class, because I didn't want to include all the math library, so I have this quad here, which only contains the functions that I need for my purpose of calculation of quaternion here. And so the output data of this bone is going to be the transform XYZ, scale XYZ, and the quaternion I calculated here. I do not have to do it in the engine anymore. So it will be XYZ and W. So let's first talk about the main. I create 3 global variables, vectors, for these 3 data type. And this booleans is going to because we are going to ignore the first 2 bones of the humanoid. So by checking the name, I will just know it's a humanoid or teddy port. Let's first talk about the hierarchy. The hierarchy have global variables, checking heart, hierarchy index. So just skip the first 2 of the humanoid and keep calling this display hierarchy functions recursively. This is quite simple. And this one is going to ignore the teddy z-sphere bones. So this is also here, and it's also in the animation one. This function takes a parent index, and which in each loop or each time I run this function, I create a hierarchy data type and set an index, set a parent index, and this index is going to be pushed to the next functions, and the hierarchy index is going to keep incrementing until I finish the last of it. And this one will be populated, and I have data ready for me. Then let's talk about animations. Animation is also the same, but why does it have to be a 3-dimensional vector? Because it has different stacks of animation. Each stacks of animations, I have frames. Actually, they used to have a layer here, but we are not going to use the layer this time. So I saved myself from creating a 4-dimensional vector of bone data and stack and frame. So in each stack, I know how many animation do I have, push the animation data. So this one is actually acting as a header for this stack of animation, and yes, and push the 2-dimensional bone data to the bones. In this one, I encounter a lot of frames. The frames, I will just know the frame count of this animation data and the bone count in the end of the loop. Yes. And for this one, I push the vector of bone data and keep running this display animation keynon and ignore the teddy z-sphere and display the channel. Over here, I create the bone data and calculate the quaternion inside the converter and push all the data inside. And in the end, I have these 2 ready for me, all of them. I push them into the file, create a new file by this name of the input, and hierarchy data, chunk header, and push it in. Animation data, the animation data, the file. No, this anim data, which is the header. Put that in. This is going to indicate the size of it, going to indicate how many stack of animation do I have. And here, the bones is a little more complicated. It's a 3-dimensional, and I can only push 1 vector of data at a time. So this is going to calculate the entire size of it, and then I have to push that each stack by stack and frame by frame. So in the end, get the first element and push all of them into the file, and gradually it is in the memory is contingent something. So I can just do that, and at the end I have the custom file created and have all the data I need inside. So let's now just create a new executionable, and it should be right here. I have it. Take it. Let's go to PA5. First put in converter, and this is a batch file. Just going to run these two commands: humanoid fbx, humanoid dude. Convert that, and let's check the game engine now. Need to keep an eye on what the convert process. Okay, let's first talk about the game CVP. What do I change? Well, I create another camera, good, and then I have created two game object animations, Teddy and human, and this we're going to pass into the create new skeletons, and also this is the file name. Oh, the file is created. Let's have these two, grab them and put it into the source folder, replace the old one. Yeah, I did it multiple times before. And so what is a skeleton? Oh, skeleton is a skeleton in animation part here. It holds pyramid model shader object, which is going to construct the skeleton we have here. This game rigid, it is a game animation type, game object animation type, because I used to call a game rigid. I didn't change it, and it has its own time. It's going to update by itself, and this time T current is going to update all of its bones and animations. So, and also I have an animation link, have with animation object, and this link is just going to linking this animation object to animation node and link them. So this skeleton itself is when I take the file name, well, I first create a pyramid model and shader object, and this P rigid, I put that into the game object manager, link to its root, and I will just grab that because this is a thing that is going to be the root of this skeleton. So right now, all the thing I created earlier is just going to affect where this whole skeleton is going to be placed in this world. And this one, I should remove that. Yes, this is going to change the location of this and also the orientation and size if I have this scale active. After that, I start setting hierarchy. It's a reverse process of what I did in the converter. This one, get its data and eat the chunk. So set the firstborn manually and push that into the game object manager. So what it's going to do is it's going to start linking like playing with the tree, and this parent, this one set manually, is the game rigid, which is the anchor point of the root of this skeleton. And the rest of it, I'm going to create a new one and have its index, add this one into the game object manager. The parents, I'm going to find it right here by myself inside the skeleton function. Why? Because inside the skeleton class, because I have the root of the skeleton, so I do not need to go to the game object manager, and having some risk. If I have multiple skeletons, I search my parents by looking at the index. So if I'm in the game object manager and run through all of those game objects, I could find someone with the same index, and that would be horrible. So I'll do the searching here, and then I still use the game object manager to construct the tree, but then I will just finish creating a hierarchy, and then the next step is animation. Also animation, I get this animation data, and the size of it tells me, the chunk size of it tells me how many animation do I have. So by having that, I will get this bone data, and I will run this stack by stack. In each stack, I will create a new animation object. So let's talk about animation. Animation is, say, yes, is the header file. This is a frame bucket. A lot of frame buckets. Lots of frames. It knows number of frames. It knows the number of bones. And this index is just help me to identify which animation I am having right now. So it takes the raw data. It knows the bone count and frame count, so it can just run through this loop. Each frame, create a head of this frame, and loop through all the bones and put those data inside. I increment this buffer and one at a time. So at the end of it, when it comes back, this bone is going to be empty, and luckily I have the start here, so I can delete that. Also, after I set all these animations, I create a new one. I pushed it into the skeleton. So the skeleton is also a manager for animations, which it is going to hold inside this animation link, linking animations together. Private add to it. Set. I also can find it by finding the index. Set the current animation to it, and that will be it. That's the import part, and it's also important part. And then let's talk about update. I have a skeleton manager. I create this new skeleton, put that into the skeleton manager. This is quite simple. It's just it also has a skeleton link. I don't know why I put everything in links, but this is maybe we can expand this feature in the future, but right now it's serve the purpose of linking skeletons. You also set the current skeletons. So it has a lot of functions: process animation, update skeleton all, update animation, post all, update times all, and all of this is just run through it and update every single one. And also I can call this update all, which is just going to do all these four in one go. So here, and I'm not using the game object manager to update the skeleton anymore. I just use this skeleton manager and let them do it individually, because each skeleton has its own time, and the time it can be paused. What do we mean by pausing time? Because let's say it's so all the other functions like process animations, just going to call this current animation, process that by passing its own time to it. This I didn't change any of this. It's just straight copy paste from the demo, and yes, all of it. And update skeleton, it's also just run through, because I have the root of my skeletons. Remember when I grab it, when I initialize this skeleton, and so I don't have to go to the game object manager to do things over there. I just start here and run through every one of them and update it. Then the update time is right here. I have the delta time that T delta, T current, and T frame. What are those? T delta, it indicates how fast it is adding, how fast time goes, and T current is initialized as 0. T frame initialized this is hard coded right now. I could be put as a input variables in the future, but right now this is serve this demo. And yes, and the update, let's see the update time. It's just going to first check, is this paused? Is it paused? I just do nothing. If it's not paused, I will add the delta time multiplied by time time of this frame, add that to the current time. And because this T delta could be going negative, so if it's going below 0, this will be decreasing. So this whole animation is will be going backward. Okay, so let's see how does it performs. The camera demo input, I also sneak the skeleton manager here. So when I press Z and X, I'm going to run through this switching between humanoid and Teddy. Also the red is corresponding camera, and 1, 2, 3 switching the current skeleton, active skeleton of the skeleton manager, and set its current animation as the first, second, or third one. I and O is going to increase and decrease the speed, which is the T delta, and P is going to pause this current skeleton. And so where's it? There we go. So right now, let's move back a little bit. So pressing 1, because it's currently doing the first one. 2 is the punch. Pressing N and make it go faster. Yeah, come on. And then get shot. Can switch in. I can pause it. If it's paused, all 3 animations is going to pause. So, but you can notice in the background, the Teddy is still chilling. Now I press Z, switch to the second one, switch to Teddy, and I can switch its animation. The third animation is just frozen. And also I can increment the speed. Let's go faster. Dancing, and then I will pause it. Go. Also switch back to humanoid. Humanoid, let it go. And if I decrease the speed, go below 0, it just start moving backward. And you can see running backward. It can go super fast. And that's it for the demo. And let's exit that. See, there's no memory leaking because at the end of demo, I just destroy everything. The skeleton manager destroy, the game object manager destroy is going to take care of all these bones I created, and the skeleton manager destroy, for here yep, it is here. I just going to clear all these animations because the skeleton itself is a manager of animations, and also destroy these two, so there's no memory leaking. Good. And thank you. That's it for the demo.